Okay, now guys, for this first one that we did, I just wanted us to chat about the A value because we didn't really discuss about what the sign of the A value does. Just again, the standard form is A over X. All right, so whatever is there in the numerator of that fraction, that is A. So in this case, what is my A value? Not just 2, but -2, right? So guys, what the sign of your A value does is it tells you, like, I don't want to say which quadrants, because the asymptote shifts the quadrant up or down, but it tells you kind of in which portions of the Cartesian plane your graph is going to be. So you'll see now, we're going to draw one with a positive A value, which you can consider. But when your A value is negative, your graph is going to be in the top left and bottom right corner. So kind of like quadrant 2 and 4, but quadrants have been shifted up by the asymptote. Okay, so I just wanted, if you have some space somewhere here, I still have quite a lot of space on the side. I just want us to write that down. So I'm just going to write if A is positive, and we're going to first do an example and then come back. But if A is negative, I am just going to draw a little Cartesian plane, keeping in mind that when your asymptote is above the y-axis or below the x-axis, that's kind of like your new x-axis in a sense. So this is not actually the x-axis, this is actually the asymptote, but yeah, you'll see when we do an example. So your graph is going to look like that, and that. And your A value is negative. It's okay if you forget that though, because the points that you calculate when you're plotting, you are going to see in which sections of the graph your graph has. So for example, I'm just going to go down again. We calculated that our x-intercept was a half 0, right? And I think we are all capable of plotting that point. We know where that point is. It's where x is a half and y is 0. So if you have a point here, guys, then if you're looking at your 4 sections, 4 quadrants, then we can see that the one part of the graph has to be here. All right, based on that point that we calculated. And then the other point that we got was -2, so -2 on the x-axis, and 5 on the y-axis. And that shows us that the other section of the graph is in this corner. All right. Okay, the next one that we are going to do, so you can just write example 2. I think we just numbered the first one as 1. You can just make it 2 there. Guys, just remind me quickly, we have already done A and Q for trigonometry. Okay? So we do trigonometry shifting up and down. And amplitude, but the amplitude was just 1, hey?
Yeah.
Okay. That's checking, I couldn't remember. Right, guys, we are going to be doing the second example. Y is equal to no, actually, we're not going to answer. It's fine. I can have it until the end of next week. No, you can solve, no? Okay, so guys, again, how do we identify that this is a hyperbola? Yep. The x is in the denominator. All right, so because of that x over there, we know that this is a hyperbola. Remember, in a textbook exam, they're not going to say draw this hyperbola. They're going to say draw the following graphs, and then they can give you like a mixed list of them. All right, or just an equation, and you must know which type it is. This Q value, this is the, you can remember, asymptote. Which one? Horizontal or vertical? Horizontal. Okay. And that equation is y equals 1. Right, the vertical asymptote in grade 10 is always going to be the y-axis. What is the equation of the y-axis? X equals 0. Good. All right, so I'm just going to add here y-axis. So guys, since the y-axis is an asymptote, then I have a y-intercept. No, all right, because the y-axis being an asymptote, that means that the graph can't touch the y-axis. So there is not going to be a y-intercept. You can calculate an x-intercept though. So just like with all the other graphs, to find an x-intercept, we have to make y equal to 0. I want you guys to solve that equation on your own quickly, please. You take the equation of the graph and you make that equal to 0. Mm. Yeah. This is it. You choose an x value. Yeah. Yeah, you just choose an x value. You don't choose a y value. The y value comes from the equation. You choose one x value, sub it into the equation of the graph. That's the y value. It has to have a specific time based on that. Yeah. It's read. Did you have a question? No. All right. Sorry, I got distracted there now. Okay. Do we have our x-intercept first? We'll see. Okay, there we go. That's what I did. Okay, how do we find the calculations? So x is negative 0. All right, guys, is that a positive? Is that a positive or negative x value? Negative, so we need to sub in a positive x value. All right, so I'm going to write that here. This is negative. Remember, we want 1 point on each part of the graph. So we have the point on the negative part now. Now we need a point on the positive. So therefore, sub in positive. Now, guys, this is your choice. You can sub in, since we have negative 6, you might want to sub in positive 6 so that it is symmetrical. If you guys want to do that, you can sub in any x value, right? As long as it's positive, but let's go with the symmetrical one. So I'm going to sub in x equals positive 6 to get a y value, yes. And to get that y value, we sub it into the equation of the graph. So 6 over x now becomes 6 over 6. Plus 1, which is 2. So that gives us our positive x value point, which is the point 6 and 2. All right, draw that graph for you guys on your own. Remember to first draw your asymptote at y equals 1 as a dotted line, and then you are going to cross the point. Cross the point so long. We might have to have another like more about it. Because the first one's make just need 2 points. No, so the y-axis has an equation. I think. Do we have to do the points of consideration? You just plot those 2 points that we talked about. And the asymptotes of the dog with that.
And would it happen? No, you should.
Take a photo of the It's just, I probably won't look symmetrical then, I just won't happen. But it's fine.
It looks a bit odd. I mean, what do I label it on?
What do you mean, like,
The axes or something.
with the equation? Why did you do them in? We haven't calculated it. Did you calculate them? So you just label them with the equation.
Like, why did you say?
They're kind of so straight. Oh,
Those
so
are
they're
cool.
horrible.
So, this is one.
Right, that you're laughing at my conversation, huh? Yeah, sure. Can someone, can anyone see the whole bus from where you're sitting? No, we're on the floor. No, that's the name tag.
Possible.
Who? Yeah, you can go, if the teacher stops, you just say, I'll bring them in now. Okay, and then.
Yeah.
Oh, here we go. Thank you.
But I think it's time to get it.
Okay.
Like,
That's character. People say it's a damage to. Okay, are we fine, guys? Sorry, it took me a while to draw this one because it's very straight. Okay, there you go. Not my best work, but I tried.
So is that
Guys, it's a little bit easier to draw if you use a scale on the x-axis. So mind you do that. What you mean? So you just use like one block for 2 units instead of one block for one. You all out to, that's fine. Right, how do we know like what direction? If it's in the top to go towards the 2 asymptotes. Yeah. So you see, this is an asymptote and that's an asymptote. So here the line, the graph is going up towards that asymptote, and it's going like flatter towards this one. The same thing on this side. Either way, the line it will always go like that in the top. All right, guys. So A is positive in this case. Thank you, let's focus. A was positive here, so do we notice that it's now in the top right corner and the bottom left corner? Right, so let's just write that in our notes quickly. So when you have your little Cartesian plane here, oops, that's always cute again. You're going to have it there and there. But again, guys, we didn't actually have to know that in order to draw the graph, right? We got our 2 points and we started there, and that obviously told us where the 2 parts of the graph is situated. Okay, we still have to find the axes of symmetry of this graph that we've done now. And guys, remember the axes of symmetry you only do if they literally ask you to, alright? If they didn't say anything about axes of symmetry, then this is your final answer and you do it like this. Alright, but let's just go over it again. So we have 2 axes of symmetry. So I'm just going to say the first one. And remember, we have a formula for that. It's y equals x plus q. And what is my q value for this graph? 1. Alright, so it's very easy. This one is just y equals x plus 1. Guys, so this line has a positive or negative gradient? Positive, hey? Remember the gradient is the f value, the coefficient of x. I'm thinking of y equals mx plus c, right? This is a straight line. So this one has a positive gradient. So it is going to look like this, right? I'm going to leave it up to you guys to draw that line. I'm just going to write the other one as well. The second axis of symmetry is negative x plus q. So that's just the formula. So negative x plus 1. This line has a negative gradient, right? Because my gradient here, the number in front of x is negative 1. So this one has a negative gradient, so it is going to look like that. Okay, please draw in those 2 axes of symmetry. You can use dotted lines for them. What? Because of the end line. No, the gradient. What's the standard form of a straight line graph? Standard form of a straight line graph? What is
Would be y equals 5x plus whatever. No.
No.
If the original graph, I thought
Yeah, it's really crazy.
6 of that, yeah. Would it, if the original one is y equals 6, 5x, then when drawing the axis, you would 5x.
The A value has nothing to do with that.
Okay.
Just with that. Asymptote, yeah, horizontal. You draw it anyway y is equal to 1 and then you label it on the side. So you have to write y equals 1. Next. And then of the Q value to go. So whatever the Q value is, that is that. Okay. With the vertical asymptote, is it always x equals 0? In grade 10. So it's the again. Okay, but in grade 10 it's always yes. And it's the reason. It was the graph can't exist at x equals 0. It was over 0. Something over 0. So x equals 0, we can now get the x value with the graph. You can't find it.
How do you work out where to go?
With that drawing the straight line,
No one that is.
so that's what you do. So
You always go outside the house.
yeah,
Basically, you only need to work out.
you only need to have one other thing. And we never really find we only find one y value. So we do the point to for what for the line. For so find the x intercept and then you must sum in another x value. Let's say grade 1. Okay, so I have that one is one of our y values and what place. Sorry, I'm almost done. I'm just doing putting in my dotted line thing for you. All right, guys, do we have those lines drawn in? There you go. They don't have to be there all the way off, but they don't have to feel that. There are a few things now about these axes of symmetry that I can tell you in order to make the drawing of them a bit faster. When we did the first example on, it was a Thursday, I think, we literally calculated the x-intercept and the y-intercept, right? And we started those. We can continue to do that, but what do we notice about these two axes of symmetry? Yeah. They go through, now listen to what I'm saying. They go through the point of intersection of the two asymptotes. I'll break that down. Do we see that I have two asymptotes here? X equals 0 and y equals 1. They intersect at what point? What are the coordinates of that point, guys? It has a y value of 1 and an x value of 0. So let's actually label that point, guys. You don't usually have to, but let's just do it for the sake of this conversation. Just hang on. So the x asymptote is x equals 0 and the y asymptote is y equals 1. The point of intersection, so where those two asymptotes intersect, is at 0, 1. Does that make sense, guys? Every point on this line has an x value of 0. That is why the equation of this line is x equals 0, right? Every point on this line has a y value of 1. That's why the equation of this line is y equals 1. So it should make sense that the point where those two meet will also have an x value of 0 and a y value of 1. They can ask you that as well, guys. They can just give you an equation, like here, for example, and they can ask you, what is the point of intersection of the two asymptotes? All right, you don't have to draw a graph in order to be able to answer that question. The point of intersection of the two asymptotes, what is the x asymptote here? X equals 0. The y asymptote is y equals 1. So the point of intersection of the two will be 0, 1. Okay, we'll look back at the other one just now and we'll also write that. So let's make a note here at the bottom. We haven't spoken about point of intersection, hey, have we? Get to it, Jonathan, please. Point of intersection of asymptotes. Going to be the point 0, 1. I'm just going to make a note again. The asymptotes were x equals 0 and y equals 1. So the point of intersection is going to be that x value and that y value. Right? That's where the two of them will intersect or meet. So guys, if that is the point of intersection of the two asymptotes, it is also the point of intersection of the two axes of symmetry. Okay, I'm going to go back to the graph quickly so we can see that. The point 0, 1, do we see that the two axes of symmetry also go through that same point? Why is that, guys? If we're looking at the equations of the axes of symmetry, what do they have in common? They have the same c value, the same y-intercept, right? This value here, that is the y-intercept of both of those graphs. I have the same y-intercept. And where did this y-intercept come from? The plus 1, where did that come from? Yeah? From the q value of the original graph, right? And the q value of the original graph gives us the equation of the asymptote. Alright, so all of these things are linked. So guys, if they ask you in a case for exam for the point of intersection of the asymptotes, it's just the x value of that one asymptote and the y value of the other asymptote. Alright, done. But that is the same point that will be the point of intersection of the two axes of symmetry as well. Also the point 0, 1. I'm going to add that now as a note. The bottom. Wave point. Stop trying to run any. How will you like for the activity? I'm going to get to that. No, not that like where but it counts is because of that. All right, so guys, we're fine with that y-intercept, right? We all know where to plot the y-intercept. There you go. There you have the point on both of them at 1. Yes? No, 0, 1. 1, 0 would be over here. Wait, x is 1 and y is 0. Okay, now, guys, what we did on Thursday is we took the equation and we made y equal to 0 to get the x-intercept. You're still more than welcome to do that. What would the x-intercept be if we did that? If we make y equal to 0, x is going to be -1, right? So you can calculate that. X-intercept is going to be -1, 0. Just like with any graph, to find the x-intercept, you make y equal to 0 and solve for x. So when you do that, you are going to plot that point over there, right? -1, 0. And then you will connect the two. Or you can work with the fact that your axis of symmetry, guys, what is my gradient here again? 1 and -1. So if I want to write the gradient as a fraction, right? What is 1 as a fraction? 1 over 1. So we can do that counting thing as well. Because that's one axis of symmetry. I think I did say this on Thursday. You don't have to actually show the coordinates here. Okay, it's not like a normal straight line. If it was just a straight line and they say draw this straight line, then you have to show the coordinate of the y-intercept on the x. Okay, for an axis of symmetry, you don't actually have to. So if we're doing this counting thing, you go one up, one to the side, right? Plot your point. Okay, and connect them. You can do it like that as well. For this one, the gradient is -1. So we can write this as -1/1. Which means from your y-intercept, you're going to count one down and one to the left. Sorry? Yes, that one. One down and one to the left. Okay, which will get you that x-intercept anyway in that case. It will have, like Jonathan has been saying, a 45-degree angle always. I think you might have done this as like an extension example in grade 9. That a straight line with a gradient of 1 or -1, well, 1, firstly, always makes an angle of 45 degrees with this axis in this case, this asymptote here. And this one makes an angle of 45 degrees on that side. Or what would that angle be, guys? If this is 45, this one would be 145. Okay, you don't really have to know that. You can just work with the points. If you calculated the x-intercept of this negative gradient axis of symmetry, it would be +1. Okay, so we would plot for +1 y-intercept, +1 x-intercept, and finish. I'm just going to add that here on the side. You're more than welcome to use the x-intercept method, guys. It's very quick. Alright, because what are you going to do? You're going to make that equal to 0 and just move the negative x over, and it's going to be positive. Alright, so the x-intercept here is 1, 0. Okay.
So these points.
The x asymptote is 0. Alright guys, we haven't discussed the domain and range yet of a hyperbola. It is obviously a little bit different from a parabola. So I'm just going to go up to the graph with me.
Or these are not
Yeah, that's the graph. Alright, domain. And range. Okay guys, what do we think about the x values? Let's first look to -infinity. Do we agree that it's going to go towards -infinity, right? Because of that arrow. And on this side, it's going to go towards +infinity. But where does this graph not exist? At which x-axis, oh sorry, x value, hang on, can I not find a value for this graph? From someone else? X. Yeah, at x equals 0. Alright, so but guys, this graph exists. It is everywhere except for where x is 0. So the quickest way of writing that is to say that x is an element of real numbers, but then use a semicolon, x cannot be equal to 0. Okay, so XER, x is everywhere except for at that asymptote at x equals 0. So you have to say x cannot be equal to 0, right? You can't have a point there. And then guys, the range is going to be very similar for range. Now we're looking at the y values, right? It's going down, down, down. There's an arrow there, so -infinity. At the top, it can carry on going towards +infinity. But where does this graph not have an actual y value? Where can it not? At 1. All right, so we're going to say y is an element of real numbers, but y is not or cannot be equal to 1. Okay, can anyone think of a different way of writing that? What want to write it using that notation? And negative infinity to 1. Alright, if we want to write the range, I'll do the same for the domain. Guys, if we're looking at y, it's from negative infinity to 1, right? Not including 1. So what bracket do I use for that if 1 is not included? A round bracket. And then again, just after 1 to positive infinity. Alright, so you can write it like this if you want. I always just write it like this. I think it's the quickest. But if you want to, you can say y is an element of negative infinity to 1. So, I'm sorry, round brackets. Because it can't be equal to 1, right? You can't use the square bracket there. And then you have to say, or 1 can go, sorry, y can go from 1 to infinity. But I think the first way of writing is quicker. You can do the same with the domain. You can say x is an element of negative infinity to 0, right? Not including 0, because that is the asymptote, or from 0 to infinity. Okay, one time, guys. We're also going to discuss some other things like how to find, for example, this point, that point over there. Alright, and they ask us to calculate it. We need to talk about reflecting and translating graph. You guys read the confirmation from last year. Okay, we need to talk about that. So, yeah. And then the other thing is finding distances on the graph as well. So there's 3 like implications that we must still do before the test. But we do have that. There is one type of graph, guys, exponential graphs, but that is not going to be in the test, so we're only going to do it after. Okay. Yes.
You don't have time to find questions.
Oh yes, we have to do that as well. Yes, thank you. That's quite important. We are going to do that as well. Yeah. Okay. Guys, I'm just going to give you some of these to practice on your own. So it is exercise 8.3. On page 170.
And would we actually label the vertical asymptote?
No, because you do kind of label it up with a line. So it is, I mean, it's the line. Alright, guys, for these 3 hyperbolas, we're saying let's find the asymptotes, any axes of symmetry. Alright, so you are going to have to do the axes of symmetry for this one. Intercept with the axes, and then also another one. So basically what we've done for the second.
Okay.